Hi, good morning, everyone. This is Nicole Testa with FIATech, and today we have with us Doug Foran and Mike Lee, who are going to be talking about mobile green-powered security and communications applications. And before we get started, I wanted to just go through some administrative items, as well as introduce our two gentlemen today. First, for those of you who may be using GoToWebinar for the first time, you are muted. That is the default setting, and unfortunately it cannot be changed. So you will find on your toolbar, tool menu, there's a question and answer tab. If you click on that, there's an area there where you can type your questions. Those questions will go directly to me, Nicole, and periodically throughout the presentation, Doug and Mike will pause or I will interrupt if it's not necessary and get clarification or have your questions answered. I will not reveal who is asking the question or from what company they're asking the question, so all the information and education is completely anonymous. Mike and Doug will also provide us with a copy of the presentation, and we will post it on the FIATech website following this webinar, so you can get copies of that. And Doug and Mike will include their contact information at the end of the slide set so that you can contact them directly with any follow-on questions or comments or inquiries. Last but not least, I know some of you have typed to me in the past. There is a little thumb sticker, I don't know what you'd call a flyout, if you will, on the side of your toolkit with an arrow that's facing the right side of your desktop. If you click on that, it'll actually minimize and hide that entire toolbar. So if that's annoying to you when you're trying to see the presentation and you're trying to figure out how to get that off of your screen, that's how you do it, and then you just hit on the arrow to open it back up. And with that, I want to introduce Doug and Mike. Doug Foran is an entrepreneur engaged in bringing new technology solutions to traditional markets. His current focus is on gas and oil and chemical manufacturing, safety, construction project security, green power solutions, and business travel technology. And as an aside, since this is a FIATech member-only event, Doug was also the gentleman who helped FIATech write our strategic plan, our 3-year strategic plan, which is embodied in the FIATech Outlook document that's been distributed to all of you. Mike Lee is an entrepreneur and pioneer in the use of green-powered platforms for site security and communications. He's an inventor with patents pending for managed wind, solar, and fuel cell power sources. He's currently the Chief Technology Officer of Critical Power Solutions. So without further ado, I will hand it over to Doug and Mike, and again, type your questions. I'll keep an eye on them and ask them, and we'll get this show started. Thanks, Doug and Mike.
Great. Thank you, Nicole. We're very happy to be here to present today, and we'd like to wish everybody happy Earth Day. At least that's what we're celebrating here in the United States. And couldn't be a better day for talking about green-powered solutions. It was serendipitous, certainly, that we got this set up, but nonetheless, we're thankful for it. Certainly topical. The other thing that I know this is Tech Tuesday, so there's a bunch of guys who understand technology out there on the end of the line, and you'll probably appreciate the fact I'm now speaking the speakerphone using my cell phone. We came into this very high-tech facility this morning simply to use the facility for the speakerphone, conference phone, and we got a message that the DHCP server couldn't boot the phone. So I don't know what happened to plug and play, but we're doing it on cell phone technology, and I hope that it's not causing you a problem. The other thing I'll say is that I sort of represent the face to the market with respect to the products that we have, and I understand this is to be and that's not a problem for us. And actually, Mike, a real resource that you who are out there should take advantage of in terms of questions, because Mike has been working to solve the problems of extended deployment using green power and sort of marrying the issues of green power and mobility. And that's not an easy problem to solve. And so if I'm going to be sort of the color guy in this description of things, Mike's going to be the expert. And so you should feel free to have a conversation with him, and we'll take the questions from Nicole. And I'll sort of get things kicked off here by talking about some of the challenges that we're faced in varying mobility and green-powered solutions for site security. And you will also see that there's a bunch of other applications that we can look at. But basically, the practical issues, and you're talking to guys who've been working the problem for a while at the street level, is, what can we do today, or what some practical advice can you give us? And we'll talk about a few success stories. And inside that, we have made up what we think are some applications that really might work well for the capital projects world. And we'd certainly like you to judge that and tell us the kinds of things that you may see applications for in this world, and then general questions. I think the proper way to do this, after Nicole has coached us some, is to go ahead and ask us questions as they occur to you, and Nicole will just jump in, and I'll try not to run all over things. But we're really the real answer in sort of understanding these things is, what can we do today? I mean, we've got a lot of variables that are going on simultaneously here that are not well controlled in one sense. We've got new technologies, especially in the areas of power generation that we're talking about. We've got a great demand for different applications. And in fact, these technologies that you see in front of us all have to be balanced in some way to solve the problem. And we'll talk about that, actually, each one of these particular intertwined technologies as we move on. The interesting part to us is that, and I think you can see my cursor, we're really at the front end of applications that are using various green power sources. And this diagram is not scientific, it's notional. But the basic message that we're trying to send right now is the more and more sensors are consuming less power, because this is one of the big issues that force people to put things like diesel generators out on platforms that have to be serviced a tremendous amount, or in fact don't even meet the application need. And the kilowatt per dollar of green power is going up, and you can see that in the not too distant future we can talk about the constraints to applications today that are pretty much power and cost constraints. And but we think that those things are changing and changing rapidly, and we'll speak to that a little bit. So I'm going to jump into each one of the different elements of generating power. We'll talk about wind power and some of these issues in front of us. And I suspect most of us, you can see the wind power turbines on the left that are the 60 megawatt kinds of guys. But we're playing in a different regime. We're down in the 600-watt regime when we try to marry mobility and green power together. And what you see on the right is a device that actually is one of our platforms that uses solar, wind power, and battery and fuel cell technology all combined. But the wind power generation is in the 600-watt range. And so this slide, because there's a lot of educational issues that go on when we deal in this. So if you're not familiar with this group down here, the Renewable Energy Lab, the National Renewable Energy Lab, NREL, they're a great source of information about the different types of energy and how you can harvest it from natural power. And, this slide here shows what the United States looks like, and the darker the blue, the higher amount of energy that you can harvest from the wind. And so, this is a national average, and these guys do a great job. Here's what it looks like in the winter, and you might guess that there's a lot of wind in these various areas in the wintertime. And the summertime looks like this, and you can see that there's some areas of obvious concentration where banking on wind power makes a whole lot of sense in terms of generating energy, and just so happens that Mike and I both live in Virginia, so that when you get down into the fine structure, one being not so hot for wind in terms of amount you can generate, to 3, 4, 5 is the top amount in terms of generation capacity, you can see that actually the western side of Virginia is a pretty rich area to mine with respect to doing these kinds of things. So, again, this is by way of saying there are resources out there for you to find that tells you the kinds of things that are available for the various geographies that you're looking for, and this is the wind component. So I'm going to ask Mike to talk about some of the things that he's run into in his long course of trying to bring these things to market on the wind side. Mike, have at it.
Thank you, Doug. I'd like to clarify something first. With regard to wind, when you're looking at the big megawatt wind generators that you see out on the top of the mountains, those are primarily feeding power into the grid. With the situation that we have here in the United States, we've had situations where mass storms have come in, like Katrina, and the grid was down. So if your concentration is feeding power into the grid, then you've got to protect your grid at all costs. And your grid then is your delivery mechanism. What we have focused on, because in security and in communications, we need to be up and running all the time, we've focused on autonomous, independent power systems that run very specific applications. And those specific applications have to do with mission-critical requirements in the field. Our company was started about 5 years ago, and the whole purpose of the company was to develop solutions that we could put security and communication sensors wherever we need to put them, not based on where grid applications are there, where the grid is available, and not based on refueling generators, because the systems that we're putting out were going to be out there for an undetermined length of time. So if you've got a short-term mission, then a generator will work fine. But if your mission gets extended, like a construction site that doesn't have power, like a perimeter fence at an airport, like military bases, like the perimeter fences at nuclear power plants, you don't have the luxury of leaving them out there for a short period of time and sending someone out to refuel platforms. You've got to be able to put things out there and be able to rely on them to provide the security that you're looking for. We started working at airports primarily, and the airports, because of the TSA contract, I was responsible for surveillance on that contract, and we had to come up with ways of putting perimeter security in, and we were getting bids of $25 and $30 a foot for trenching, and that was more of an infrastructure project than it was a security project. So we tried to work with just solar, and then went with the combined solar and wind, and it started working, and that's when we started the company and started producing these units. If you look at the consumer versus industrial strength, I think that's where you find the biggest difference. The big industrial strength wind generators are designed for grid-type applications. Consumer units, the ones that start at about 250 watts and go to 600 to 1,000 watts, to a kilowatt, kilowatt and a half, are really designed for smaller applications, but nobody is using them on portable platforms. So we started putting them on portable platforms. If you look at the cost per kilowatt hour, and I think if we look at both solar and wind, all the renewable energies are very expensive to pay out in any kind of reasonable way compared to our grids. If you look at the grid is about $3. I pay $3 or 3.8 cents a kilowatt hour for power. And in wind and solar in the smaller ranges, you're more in the range of, with a 1-year payout of about $1 a kilowatt hour. So it's not even close. Now, if you look at how the payout works, though, over a period of time, it gets much better because you're not paying for refueling your power generation as you would with the generator. So if you pay, let's say you pay $1,000 and you're getting 1,000 kilowatt hours for the year, if you spread that over 3 years, you're down to closer to 33 cents a kilowatt hour. So that starts to become much better. So the outlook for the near term, there's a number of things that we've done with regard to using these generators out there. There's a lot of issues you have to overcome. There's such things as vibration. The wind generator vibration becomes something that you have to deal with if you're doing long-range video surveillance, primarily only long-range video surveillance, where any movement in that tower whatsoever is going to cause movement in your picture. The more we move from the just pure surveillance to surveillance that's now using software algorithms to determine what's going on out there, those algorithms are no good if the picture isn't stable. So we've gone to using software stabilization in the security surveillance platforms and securing the platforms to the point where we get much less vibration. The size of the wind generators has been important. I think when Doug showed you that first picture of the smaller wind generator over on the right that was a 600-watt wind generator, we designed those systems specifically for airports under FAA regulations. For every foot you move back, or every 7 feet away from the airport, you can be 1 foot high from the runway. I'm sorry, from the runway. So these are designed to be 10 feet tall and be placed 70 feet from the runway, so that we can read tail fin numbers on airplanes that land late at night at places like general aviation airports. So they're very specific purpose, and the reason that they're out there is to build a revenue stream for the airport that doesn't normally have the ability to do that. Would you like to talk about the solar? Oh, the horizontal versus vertical orientation. Well, as we look at the changes that we're seeing now in the wind generators that are available on the market, we're seeing some interesting technology come about with regard to the vertical orientation of these. Some of them, what we're trying to do is get to a point where we can deploy wind generators that can go absolutely anywhere, and be effective. Now, what we're trying to do is get them so that we can put them inside towers, be a little creative with where you can put the wind generators. So, number one, they're safe from any people, so that the people can't get close to them, but also generate enough power to be able to run the very specific devices that we're putting on them. Great. Okay, well, thank you. Nicole, any questions coming in right now?
So far, we don't have any questions.
Okay, great. Well, then we'll just keep on going. Again, what you see in front of you is something that's probably pretty obvious with respect to where the solar energy resources are, at least in the United States. And this chart's good enough that you can actually see the number of kilowatt hours per meter squared of solar material that you can generate in a day. And so even the yellow areas and so forth that appear, say, along the East Coast, you're still looking at, 5 kilowatt hours per meter squared a day, which is a pretty reasonable number. And you can also see that where the sun is happens to complement some of the wind concentration areas or areas where there's lack of wind. So again, another reason why the multiple sources are really needed to achieve the deployment goals that we have with respect to, ideally putting things in the field that stay out there forever. So I'm not going to take you through every different season and so forth, but this is just to give you an idea of what those resources look like. And Mike, maybe you can contrast some of the issues here with respect to solar power that you're using.
Yeah, the cost per kilowatt hour, surprisingly enough, in the lower power range where we're dealing, is right about a dollar per kilowatt hour as well. Just about the same, right in the same range as the small consumer-based wind generators. So you're looking at if you extend the cost of the wind generators and the solar panels out over a longer period of time. That's why they always talk about a payout being 15 years for wind generators. It really is, and for solar panels, it's in that range. Now, the thing that you always run into with solar is that the more power you need, the bigger the size, and that's where the industry is today. We're trying to get to the ranges of a kilowatt of power in a 1 square meter range, but that is a long ways off. We're at about 250 to 300 watts per square meter of space right now, but it's getting better and better. The outlook for it is getting better because of the nanocell technology that's coming. With nanocell technology, they're going to be able to get more power out of a smaller area, so that using the same size considerations that we have today, we'll get twice, 3 times the power. We are now about 12 to 14% efficient on the solar panels that exist, and using nanocell technology, it is estimated to get up into the 35 to 40% efficiency rate. Now, using those types of rates, we'll have quite a bit more power generation capability on the front end. We've looked a lot at sun tracking, and the sun tracking where it follows the sun. And when we're dealing in the power environments that we're dealing in, which are very low power, we have to control the power consumption tremendously. It really doesn't pay that much to track the sun, because the cost in power of tracking the sun is not worth it in the amount of power that it generates. So if you orient your solar panels correctly, then you're going to be able to have the kind of power that you need, the maximum that you're going to get out of those panels, almost. Moving to fuel cells, we use a fuel cell for one reason, and that is because of the absolute efficiencies that are built into the fuel cells. If you look at the picture there, we've got a Rely-On fuel cell there in the middle, which is the I-1000. The Rely-On fuel cell is a PEM-based fuel cell. It's one of those that it requires the hydrogen tank beside it, and it feeds off the hydrogen tank, and the output of it is just basically mist. The only reason we use the fuel cells is to back up the solar and wind, so that you have a power generation capability on the platform that allows you to bring some power to bear when you don't have any wind or sun for an extended period of time. All of our platforms are designed to run at least 5 days, sometimes 6, sometimes 7, depending on where they're going in the country or in the world. They're designed to run an extended period of time without wind and sun, and all of our platforms are monitored as well. So as you watch the batteries go down in the dead of winter, and the wind is not blowing, and the sun is hidden for months or for days on end, we need to have a power source, and we're using hydrogen right now as one of those power sources. Now, we're not recommending hydrogen because we want you to have to go out and find another fuel source. We're recommending hydrogen primarily because of its efficiency. The difference between a generator, so you have a 5 kilowatt or a 10 kilowatt generator and a 10 kilowatt hydrogen fuel cell, is that a 10 kilowatt generator running 10 kilowatts, a 10 kilowatt load, will burn the fuel the same as if it's running a 1 kilowatt load. The hydrogen operates different. It operates such as it only burns as much hydrogen as is necessary to carry the load. So from an efficiency standpoint, we gain in efficiency by putting hydrogen on the platform. Now, if we do a lot of work with DOD, and because DOD has technically a diesel component to their mission or a fuel component to their mission that is not hydrogen will go along with what they want, because it's always mission-oriented. If you have a diesel component to your mission, if you're doing a big construction site and you've got a lot of diesel fuel that's there, then we can put a diesel generator on as a backup component. That would be appropriate. But if there is no other fuel source with regard to the mission, then we would recommend hydrogen first. One of the reasons for doing that is because we now can create hydrogen in the field. We generate an awful lot of power on these platforms during peak power performance. Peak power is when the sun is directly overhead and the wind is blowing 22, 24 miles an hour. So in that condition, we're generating an awful lot of power, and under normal conditions, we throw it away. Instead of throwing it away, we redirect that excess power now and allow that to go into an electrolyzer that takes a tank of water and converts it to hydrogen and oxygen. When it does that, it pumps it into a tank so that now we're creating our excess fuel in the field using excess power off of the platform that is being run by solar and wind, and it's doing its job. So it's out there doing its job. It's communicating, or it's providing surveillance, but using the excess power, it's refueling itself in the field. Now, that is a breakthrough that we're doing that is pretty creative, and hopefully we'll be in a position where these are commercially available very shortly, and we'll be able to start deploying these in areas where there is no power out there. We always have issues with hydrogen safety, and that really depends on where these platforms are going. The tanks that hydrogen goes in, you're all familiar with the tanks for the welders and the different gas tanks that are out there, but primarily if they're in a fire zone, we're not going to be, a fire meaning live fire zone, we're not going to be providing hydrogen in that type of environment. But in areas where we can have the tanks and it's not in dangerous territory, we would go with that. Now, battery technology is getting better as well.
Excuse me?
Battery technology is one of the things that we keep screaming about, because technology is getting a lot better for a lot of the devices that are out there, but battery technology seems to be lagging. It's getting better now because of the emphasis on hydrogen cars and electric cars and the technologies that they've been putting into lithium-ion. It's very impressive, and they're getting much better cost-performance ratios out of batteries. However, when you look at batteries, you've got to take into a lot of consideration. Now, the list that's on the screen there is a number of different battery technologies that I'm not going to go through all of those because we don't concern ourselves with most of those. What we try and do is price the batteries to the pick the batteries based on price and performance. And I'm going to give you a couple of examples of that. Some of the things that we get concerned about is the size of the batteries, the weight, temperature ranges, and price performance. But I'll give you an example. We were asked to do a project for the Marines. We bid on this as an RFP. It was a 5-kilowatt generator they wanted to replace with a 5-kilowatt renewable energy production capability. So a 5-kilowatt generator being replaced by renewable energy. And the caveat was they wanted it to run for 48 hours on battery alone. 48 hours, 5 kilowatts. If you take our standard batteries that we use in our normal platforms, that would have taken 18,000 pounds of our batteries to run 5 kilowatts for 48 hours. Using the lithium-ion batteries, the best lithium-ion batteries out there in the field to run that same equation was 6,200 pounds of lithium-ion batteries. So if you start to hear it in my voice, it's not the kind of thing that is easily done. We can't just go out and replace a 5-kilowatt generator. What we came back to the Marines with was a solution that made sense. Making sense in a solution using renewable energy is simply taking out your mission-critical applications out of that 5-kilowatt load. Remove those, your mission-critical communications, anything that you have to do and have to have, we can now run using renewable energy. But we're not going to be providing, part of that 5-kilowatt load being air conditioning in a Quonset hut. We just can't do it. It takes too much energy to do that. So those are the kinds of things that you have to do. When I say price performance, that 6,200-pound lithium-ion battery pack was $150,000. So we're paying a lot for batteries and battery technology, and it's not the direction that we have to be going. What we have to be looking at is reducing our power consumption on our mission-critical applications down to the point where we can run them on an acceptable size renewable energy platform. That's what's important.
Mike.
Yes, ma'am.
We have a question. What is the relative cost of a hydrogen power cell?
A 1 kilowatt is about $8,000.
And that's the beauty of this system. There's silence at the end. Great, thank you, Mike.
Oh, good. Yeah, right. We don't. Oh, okay. Yeah. So we didn't hear anybody gasp or anything like that. I think that. So now that's $8,000 per kilowatt continuous power. Well, yeah. Right. Okay. Right. Yeah. But it's not the annualized cost. Oh no. Right. Okay. No. So I just wanted to make sure that. No, that's the cost of the actual hydrogen fuel cell. It's about $8,000 plus tanks, and depending on how you want to deploy it. We have a 1.2 kilowatt generator, and it goes up to about 1.6 kilowatt generator for about $14,000 that comes in a self-contained unit. But the nice part about this is that these all communicate. They all have IP addresses. So they communicate right in with our system and become part of the platform. So, speaking of the platform, if let's move on to the next slide of picking the right platform. We build platforms based on the requirements of the mission. Now, because we're about the only company out there that is focused on mission-critical applications using renewable energy. There's a lot of people that have gone after mission-critical applications just throwing products together and trying to make them work. We go after it and go after it in a very big way. The platform itself is what we build based on the mission requirements. That bottom left-hand dual-axle trailer down there has about 3.5 to 4 kilowatts of peak power performance being generated on that. That apparatus that is running on the top is a ground radar system with a very large FLIR Ranger 3 camera system on the top. Range of that is, the camera is about 7 kilometers. The ground radar system is slightly longer than that. That's the same ground radar system that's being used right now by Boeing down on the border in southern border of the United States. But that platform is designed to, you notice the wind generators aren't up very high. That platform right now is out in Nevada at a very secure location with the federal government, and it sits up on top of a 5,500-foot rise in the ground out there in the middle of the desert. And they needed to have 360 capability on the ground radar system, and the wind generators down below that. Normally, our wind generators would be well above the apparatus for the mission, but this is an example of one of the things that we do. We also make almost all of our platforms are very low profile, so that they can be pulled on top of a parking garage. Now, that's important after Katrina. It's important after some of the other situations that we've run into where we've got power outages in cities. where we have to go in and set up emergency communications very quickly. So as you look at that slide, we have mission factors that are always involved in the products that we build, cost factors, because we can't be out there building $400,000 platforms that are going out to do a job that would require much less than that. And of course, we're always in the business of environmental stewardship. Picking the right components is critical, and that actually gets to the real guts of what we do as a company. We match the components and the power, and picking the right components is critical. That ground radar system that you see on the right, when they came to us originally to run it on the border, they said we needed 27 amps to run on a system down the border. 27 amps is well out of our power range, and I'll explain that more clearly. It's not out of the range, but it's for long-term deployments, that's a lot of power. So we gave them a 6-amp power budget. Now, the company that was doing the integration on that is a security company, and a good one. They came back about 4 months, 4.5 months later, and they said, we are at about 6.2 amps. Can we now do it using renewable energy? Well, that's the key to the whole idea of using renewable energy, is to bring the power consumption down by not changing the mission, but changing the way you do the mission. What they did is they had chilling and cooling devices out there because they were hosting a lot of equipment out on the platforms that they were building previously. They also had, the equipment was being monitored right there on the platform. Now, if we want to change the mission a little bit, transmit everything out of the platform to a remote location where now you can truly remote your sensors, your ground radar and your video surveillance can be way out, away from you. It's now transmitting the data back, and you're not doing anything else out on that platform. That platform is now unmanned. It's silent in the field. It has no heat signature to be picked up by anybody coming across the border. And all of a sudden, you've got a brand new capability that you never had before. That bottom picture right there is one of the smaller units. They're designed for airports. It's got WiMAX antennas on that, or those were before our WiMAX antennas, but those are designed for wireless IP networks, and that is designed so that it can go up on top of a parking garage as well. Now, that upper left hand is a battery bank on one of the platforms with a hydrogen fuel cell on it, and that's the tank for the hydrogen fuel cell. So we match all of that and put it into an equation that makes the kind of sense that what this shows here in front of you. Every system that we use has 3 components to it. It's got power generation, power storage, and power consumption. And all of that has to come into balance so that you are generating as much power as you need to recharge the batteries, all focused, though, on the consumption of the power by the devices. And what we try and do is reduce that power consumption. We found out over the period of several years, we failed a number of times out there, and the reason we failed is because the power consumption was too high. I had the opportunity to go down to Arizona and see some sites that had failed down there that were just plain video surveillance sites. Video surveillance failing in Arizona being powered by renewable energy, by solar primarily. I couldn't believe it. But the problem that they had was that they designed the system, the components on the system, just like you were running off the grid. And you can't do that. You've got to reduce your consumption down to where you can build it into a system that actually works. Now, the final piece that we've done is we've managed that entire platform. So everything that we have out in the field now, we can monitor from a remote location. So now I can see what my power consumption is, I can see what my battery status is, and I get an alarm or an alert from every single device we have in the field. So whether you're using it for remote communications or remote video surveillance, you now have a complete power profile of every device you've got in the field. When we first started working on this project about, like I said, 5 years ago, the IT world and the renewable energy world were at the opposite ends of the spectrum. They were not even near each other. If you think about the IT world, in the IT world, we want to duplicate everything. We want to mass produce, mass produce, mass produce. In the renewable energy world, it's completely opposite. They want to build a one-off for every single environment. It means, tell me how much you're going to run, and we will tell you how big your system is going to be. How many batteries, how much solar, how much wind, and that's what we're trying to do is bring that down to a mass production point, to where we can actually mass produce devices, and I'll give you a power budget and tell you what you can run on it. The thing that has happened that's been very positive for this is that the power consumption of all the devices is now coming down and ready to fit right in our wheelhouse, so that now we can run just about anything. We had one of the cell phone manufacturers in the other day with their new devices that they have out. They have a 2-line cell phone power system that goes in the field. It's ruggedized. It's ready to go on a tower. So you can have 2 cell phone lines plugged right into this, or used right through our tower, and it runs at about 2.5 amps. So we can put those out in the field now and bring cell phone communications just about to anywhere. Now, at some point, it's all IP-based, so at some point it all has to come back on a satellite dish and come back into the system. But it's a meshed environment running all cell phone communications. So that's the kind of stuff that we can do now, because the power consumption is coming down on all the devices. Now, I mentioned something else that's kind of important, and that is that we can now unman the sensors out in the field. Unmanning the sensors means that if something came up and something had to happen to those, if a big wind came up, a storm came through, somebody would have to go out and do something to those towers. So what we've done now is we've turned these into intelligent tower systems, where there's a wind anemometer on them that will determine the wind speed. When it hits a certain wind speed, it'll automatically nest the towers and wrap the solar panels back in so that they don't become sails like on a ship. So now we have a survival mode that we can put the systems into, and we manage the entire platform. So those are the things that have to be done and make it a more intelligent platform. Nicole, how are we doing on time?
We're doing great. We've got, we've got 15 minutes left.
Okay, good.
And I think you're doing such a great job with the presentation. We don't have any more questions, so.
Well, hopefully we still got some people out there with us. So
we do.
Great. Well, we thought what we would do is we would look at a couple of case studies, and maybe we'll try to do that in the next 5 or 6 minutes. I think this is an important one to at least talk about deployment. And then what we'll do is we'll have a quick chat about some applications and see if we can get some feedback from everybody out on the line that make this particularly relevant. We think we've got some relevant applications for the capital projects construction world. So, Mike, let's talk about this rapid deployment slide.
Okay. All the units are designed to go up very quickly. This is one of our smaller units. It's designed to be deployed at airports, military bases. This is actually down at Camp Lejeune where we did the filming of this. But they are designed to be pulled by an ATV. They are not intended to be roadworthy. The smaller platform here, because those wheels come off. You actually take them out to the perimeter, and you put the outriggers out, jack it up, take the wheels off, and jack it back down to the ground. So it can sit out there as a semi-permanent tower platform, so that it's a way of putting your infrastructure out immediately.
Okay. This is a little different application.
This is the larger unit. This is what we call a Mojo. We first sold these to the Marines, excuse me, to the Marines, and the Marines named it the Mojo because it had so much power on it. But these are out at one of the TSA airports out in the Midwest, and that is actually providing perimeter security right there at the corner of a fence area. And those cameras, actually, you see the cameras about halfway up. The cameras only have a 300-yard distance capability on it, so we didn't put them at the top so that we create a hole in the perimeter. But those things create enough power out there to generate, to run the cameras and the transmitters and be up basically forever. Some of the other applications that we're doing out there at the airports, we're monitoring tailfin numbers, like I said earlier, off those little tiny platforms that we made up there. We're running RFID applications so that they can monitor where trucks are, where large assets are, anywhere in the field. We can either triangulate or you can do it with GPS tags themselves to make it so you can monitor where assets are in the field. We can put remote card readers out, running the ground-based radar for remote perimeters, but a lot of wireless communications. These things are gap fillers in the wireless communication environment.
Great. And maybe a little bit about this high-tech area surveillance.
Well, this is the concept of operations that we used for the border applications. What they're doing with that is the Mojos, the mobile units that we put out in the field, cover the dead spots in the ground radar. The ground radar has got several dead spots. As you know, it's a line-of-sight technology, and so looking behind ridges or down in arroyos in the Middle East or in Iraq, they call them wadi watchers over there because they're looking down in wadis. The arroyos here in the United States, where people cross the border, come right under the radar because they're down in the valley where they can't be seen. So you can cover your dead spots with Mojos, and all the cameras then are trained by the ground radar. So the ground radar sees the target, trains the closest camera to it, and you've solved your problems down there. The independent power station that's out there is just sitting there providing power on somebody else's tower.
Okay. Great. And so now I thought, we've been through hopefully some considerations that make a lot of sense to you from a top-down view of the technologies and some of the applications. And I got to thinking about some of the things that really might work for the capital projects industry, construction industry applications. And certainly, a couple of things that occurred to me were laydown yards, for example. It's anytime you're doing horizontal development of a site, before you start doing the vertical development, you've got security issues. You probably don't have a lot of power. You got a laydown yard where you're going to put a lot of assets that you want to make sure that they stay secure. And in fact, in the same idea of the laydown yard, you probably want to have some asset management because trucks are moving in and out of there with a lot of material, and if they had RFID tags on them, then one of these sources, green-powered sources, would actually make a perfect way of asset management for the RFID application. And then I think one of the things that you sort of alerted me to, Mike, was the issue of the communications hub. Because there's a lot of devices wandering around on sites right now, everywhere from handheld specialty devices to wearable computers and the like that are providing documents for people to understand how to work orders, distribution, and rounds, the people that are conducting rounds for either maintenance or security purposes. And so the concentration of those communications into a communications hub, and one that is pretty easy to put in place, not as difficult as our speakerphone here this morning, we can do it. So, and then of course, as the job starts to mature, you can get both the visual look at progress as well as, again, collecting the information that's needed to feed various material management systems, work process systems, and those sorts of things. So, those are several of the things that I think really obtain here with regard to the construction industry. And if there's anybody out there that's got some other ideas or would like to ask us questions, we would certainly be glad to do that. And if not, then we sure want to thank you for your time and attention. And you can see there how to get a hold of me. I'm the guy that you'll need to talk to start with, and you can email me or write at that address, tforan@redbranchtech.com, or call me on that phone number. It's with me 24 hours a day. But if there's no other questions,
there is.
I think that's it.
Doug, there is a question.
Hey.
Yes. Can the system be used to extend a wireless computer network into a construction site to allow communication between a server and a tablet PC?
Absolutely. Yes, it will do that. We do it either in a meshed environment or with point-to-point communications. It depends on what the terrain is like and how far you're going. We can do it with satellite communications as well. So there's a number of ways of doing that, and it just has to be designed right. Yeah, that's certainly the application, the kind of application I was thinking about with respect to that communications hub. And we're seeing a lot more of that happen now. So if you look at it depends on what the requirement is and what you're trying to get in and out of the construction site. We did some work for remote power substations where there is no power out there. Believe it or not, a lot of the substations don't have power at the substation. So we designed it so that it could go out on a cell phone, and the cell phone link was pretty tight bandwidth, but with the video that we put on it, it was able to go over the cell connection. Right. So it really comes down to what is available as a communication system, whether it's satellite, cell, IP, point-to-point, however you want to do it, we can do that. Any other questions, Nicole?
I think that's it. We're butting up right against lunch, and I guess depending upon where you are, I'm here in Ohio, and it is a beautiful, glorious day, so you don't want to keep people between their sandwich at this hour. But you guys did a great job. I guess when we scheduled this, I had not realized that it was Earth Day, so it was very appropriate and timely. And
that was a good job on your part, Nicole.
I think that was all you, Doug. But thank you very much, Mike and Doug. For those that arrive late, we will get a copy of the presentation. We will post it on the FIATech website. We will have a webinar next Tuesday from 11 to 12 Eastern Daylight Savings Time on global, our GVCC project on global control valves e-catalog and a cross-matching editor with PIP. That'll be from 11 to 12 with Sharon Bickford, and information will be coming out later this week. Thanks again, Mike and Doug. Appreciate it very much, and we'll talk to you all soon.
We thank you for your time, Nicole.
All right, bye-bye.